Yeah, you're the host now.
I just wanted to start a recording, and
Sure.
then we'll make you the host again.
Okay.
Yeah. That way we'll be able to save it for future viewing.
Gotcha.
And it's just about time. In fact, I believe it is time. We'll go ahead and get started. I anticipate that a few more people will probably join as we get going, but of course, those of you that join later can or miss any part of it, we're recording it so that we can post it on our website later today. Thank everyone for joining us this morning. My name is Brandon Marie. I am the Director of Member Communications for the Pennsylvania Motor Truck Association. And joining us this morning is Mark Smith. Mark is an energy industry veteran with more than 25 years experience. Currently, he is the sales manager for Advanced Fuel Solutions, where he leads a team of fuel quality professionals, helping fuel dealers improve the quality of their fuel and the experience their customers have with it. Mark also serves on the board of directors of the South Central Pennsylvania Energy Association, as well as an active board member of multiple oil and energy service professional chapters throughout the Mid-Atlantic. Mark is a member of PMTA, the Pennsylvania Petroleum Association, and the Delaware Valley Fuel Dealers Association. And Mark is here this morning to talk to us about resolving exhaust after treatment systems and fuel cold flow issues. Mark, take it away.
All right. Thank you, Brandon. I appreciate the introduction there. I'm going to share my screen here, but I wanted to give you a little information on AFS, or Advanced Fuel Solutions. So AFS has been in business for 25, going on actually 26 years now. And we provide consultation to terminals, down to fleets, to fuel distributing companies, anybody that delivers fuel, down to heating oil dealers, down to individual owners and operators. We provide fuel quality testing to keep fuels clean. An interesting note, I was on a webinar for the National Bioboard Conference and Expo last week, and somebody from one of the trucking companies, Cummins and or Ford and or any engine manufacturer, were touting the benefits of having clean fuel, especially with new upcoming EPA engines and tighter tolerances and higher temperatures with respect to injection and fuel and so on. So with that, I'm going to get started here. Hopefully. There we go. So today we're going to talk a little bit about cold flow since it's been cold out. I'm not going to spend a lot of time on cold flow, just to give you a little bit of a introduction to it. We are going to talk about some of the drivers that are impacting fuel and engine technologies, specifically in reference to a political or legislative, and also how OEMs are responding to that. We're going to talk a little bit about diesel and the cold weather and ultra low sulfur fuels. I just want to make sure this is the right one. Yep, got it. Going on then, we're going to talk about ultra low sulfur fuels, the challenge that we see with the new refining processes that have come to be with ultra low sulfur fuels, meaning the desulfurization of fuels. Talk about some articles in Transport Topics, which is the online magazine for American Trucking Association, regarding exhaust system repairs. Challenges, we're going to talk about diesel particulate filters, EGRs, not too much on the SCR system since they seem to be in pretty good shape. And then some of the changes that we're going to be seeing coming here pretty quick. High pressure common rail injection systems. This is really the impact zone, so we're going to be spending some time on that in reference to high pressure fuel injection. And then some of the other issues that come out of the fuels that we have to use in reference to generics. So those, some of you may know the names of asphaltenes. which cause filter blocking. Then we're going to talk about solutions. So let's talk first about managing your cold flow operability. So some of the terminology, the cloud point, CFPP, cold filter plug point, pour point. For transportation companies, CFPP, or the cold filter plug point, that basically is the lowest temperature that will allow diesel to flow through the fuel system, specifically the filter, without causing filter blockage and or problems. Pour point, it's more of a, we've referred to that as gelling of the fuel. A lot of times it can be a combination of gelling of the fuel if it gets cold enough, if it reaches the pour point. Pour point, of course, though, is the lowest point where when the temperature drops, that the fuel does not continue to flow as a liquid. And then cloud point, which sometimes is confused with the pour point, is really when the fuel, the diesel fuel, goes from a clear and bright liquid to a cloudy liquid with the temperature dropping. So cloud point cannot be changed. However, CFPP, cold filter plug point, and pour point can be reduced by adding pour point depressants or CFPP depressants. Nobody likes to see, especially fleet managers or mechanics or owner operators, the picture at the left. These are waxed filters. As temperatures drop and the temperature, it gets colder and colder, once a fuel reaches the cloud point, this is when wax starts to form and becomes visible to the naked eye. In the beaker to the center, you'll notice that you have a dark bottom portion, 20% of the portion of that diesel fuel, whereas the top is still pretty bright and clear. The wax fallout line, consider this as your saddle tank after it sat unadditized, meaning there was no cold flow improver in the fuel, and it sat overnight. And as the wax crystals grew, gravity took over and it fell to the bottom of that saddle tank. Of course, where do we find the fuel line? It's at the bottom of the tank, bottom lower side of the tank a lot of times. So this is where when a driver would jump in the truck and start that engine, ultimately that slug of wax would continue down the line, hit the first filter, the primary filter, and then ultimately cause fuel starvation, and the unit would not run, resulting to the picture to the left. A lot of times this is just more of a nuisance. Nobody likes to change filters out, especially when it's cold out and you get diesel on your hands. It's not a fun activity. You'll notice the beaker to the right that has been treated with a cold flow improver, or CFI, and this particular one has what they call WASA, W-A-S-A, standing for wax anti-settling agent. You'll notice that the actual mixture has turned sort of cloudy, so it's reached its cloud point. However, because wax modifiers modify the wax crystals so that they don't grow and become heavy and travel to the bottom of the tank, the wax modifiers prevent the crystals from growing and again falling to the bottom of that tank. The WASA, the wax anti-settling agent, actually keeps the modified smaller wax crystals in suspension and doesn't allow it to drop to the bottom of the tank. When you have smaller crystals, you actually have a situation where it will pass through the filter, and again, you don't get that initial slug of that wax that has fallen out. Note on the center beaker here, the cloud point of this particular, if we were to striate and take actual measurements in testing, the cloud point, the CP, was an 11.7. That's actually within normal, terminal parameters. The CFPP, cold filter plug point, was a -13 Fahrenheit. Typically on a 32 or even a 20-degree day, that's going to pass through a filter. Notice at the bottom, though, where we see the 20%. the results are much different. 27.5 degree cloud point, and the CFPP cold filter plug point is 6.8 above degrees Fahrenheit. The beaker to the right, you'll notice that even though it's cloudy, the cold flow improver with the WASA has been able to provide a CFPP or cold filter plug point of a minus, that should be a minus 20.2. So this is important, especially when units sit for long weekend holidays or over weekends and are not being used. This is the type of technology that can work in your behalf. What do you look for when you go into looking for a winter additive, a cold flow additive? Well, first of all, you want to have a couple of advanced wax modifiers. Wax modifiers keep those wax crystals small so they can pass through the filter. We expect that we'll see, just based on refining processes, we've seen a lot of water in fuels and in tanks, so we expect to find water. So let's add a jet fuel deicer. That is a non-alcohol deicer that will prevent the line from freezing, but also will help wick water out of the fuel when temperatures are above freezing. I mentioned wax anti-settling agent. Not all additives are created equal. The wax anti-settling agent is actually relatively new chemical that was invented actually in Germany, required in certain months to be used in German fuels at a certain ppm in order for them to keep their vehicles on the road. What this does though is this keeps the wax modified crystals in suspension for 96 hours or more, and this helps then to keep the filters clean and the ignition part of the combustion. Treatment-wise, they should be any additive should be treated for both terminal and/or splash blending, depending on how you treat your fuel, whether you have bulk storage or you're treating individual saddle tanks. Also should be designed, and that's why you should have more than one wax modifier in your formulation. It should work in both petroleum as well as biodiesel blended fuels. Petroleum fuels are a little bit easier to treat for cold flow. Biodiesel blends are a little bit harder, but with the right technology, you can you can achieve results that you want. So let's talk about drivers that are impacting your fuels and actually your technology. So, President Biden most recently came out with a bunch of initiatives that look like they're going to be pretty tough on the type of equipment that we buy, especially what they call high carbon type of technology, and that would be diesel, gasoline, any type of fossil fuel. So he's probably going to be rescinding. We'll see what happens, but he'll probably be rescinding some of President Trump's omissions in reference to fuel economy, as well as emissions, greenhouse gases. However, all of these the exhaust emissions and fuel economy and greenhouse gas parameters were set by previous administrations. And specifically, EPA now runs that. So legislation, what we've seen is from the federal government all the way down to the state government and specifically governor level, they're pushing for electric vehicles or electrification of equipment. We don't see that happening anytime soon. However, it is something that we have to deal with. These exhaust emissions and fuel economy points are actually going to get harder and harder for engine technology to achieve. However, they've stepped up to the game, and things like GDI, gas direct injection in reference to diesel fuels, smaller and lighter engines, turbocharged engines. These are all technologies that engine manufacturers have developed in order to meet the current EPA restrictions and or goals in reference to technology that's coming down the line, and they've actually done that very, very well. Consumer purchases will continue to drive what manufacturers make, though. So if you think about it, pickup trucks are very popular in the United States, and they will continue to, produce these types of vehicles. They will be subject to, EPA mileage as well as emissions. So, and manufacturers and actual, like Ford and Ram and Cummins, and depending on different manufacturers, will continue to develop these technologies in order to meet those particular needs. So how does diesel stack up against other fuels? Well, first of all, diesel is the fuel of choice, especially in heavy-duty Class 8 type of applications. Diesel fuel is the most dense fuel in reference to the actual weight of the fuel based and the power of the fuel based on the performance. Biofuels, I would suggest that you look at biofuels in reference to lowering your carbon footprint and the emissions. But as we get down into other renewable type of fuels, whether it be natural gas, compressed natural gas, and or liquefied, hydrogen, so on, these are all, viable. But we don't see electric vehicles coming into this classification in reference to what we're typically doing in reference to, heavy-duty excavation as well as moving goods. So let's talk about diesel fuel, how it's changed. Diesel fuel was required to be desulfurized. We went from probably around 2,000 parts per million sulfur content years ago down to 500. We refer to that as low sulfur diesel. And then back in 2006, 2007, EPA said, well, guys, we got to go for on-road. We got to go down to 15 parts per million sulfur content. Now, how did we get there? Well, refineries were required to change their normal operating and refining techniques, and they went to more of a hydrocracking type of technology. By doing so, they were able to lower sulfur by providing it with steam, steaming the actual fuel. But there are high temperatures that are required in order to do this. So as ultra low sulfur diesel was developed, we expected certain things to change and other things not to change. So some things were expected. So we knew that there was going to be reduced lubricity. There were some different storage concerns, probably a little bit less sludge or sediment in tanks in storage, in reference to storage. However, we've seen a little bit different, more granular, more dusty, almost a granite type of stability and particulate coming out of fuels. Today's fuels do have a greater affinity for moisture, and ultimately, when in the right conditions, microbial contaminations, there are fewer natural inhibitors for microbial contamination also. It is corrosive to metals. That hasn't changed. Higher sulfur fuels and lower sulfur fuels haven't changed. It is more paraffinic or waxy, which will actually impact pour points as well as your cold filter plug points. I mentioned natural microbial inhibitors that aren't there. And then it still reacts to yellow metals, which would be copper, bronze, and brass, which are part of some fuel systems, not all of them. Most of it is now stainless steel. This fuel also, because of its refining, lacks what we call thermal stability, which will come to light as we get into high pressure common rail fuel injection systems. So we have a new fuel. So what are the problems that we've seen? Transport Topics, in one of their articles, identified the left side list of different things that have been issues in our transportation and trucking industry. So excessive fuel blocking, injector sticking, what we call stiction, IDIDs, internal diesel injection deposits, power loss, fuel economy deficits, DPF regens, Egr valve deposits, gumming of fuel pumps, fuel line corrosion, not achieving typical filter, oil filter preventive maintenance intervals in reference to things like blow-by and, fuel contamination or oil contamination. In addition, in a June 7th, 2018 article, FleetNet America identified that maintenance costs for fleets rose 20% from 2012 to 2016 and accounted for 18% of the vehicle's base costs. Roadside repairs also increased and also accounted for approximately 4 times of a regular shop repair. So, this is costing our industry money. Basically, data is supporting, these maintenance repairs, and in reference to reducing them, the data leads to action. And this is where, we learn from our telematics and our information. Leading the repairs in this particular article were 2 different areas. One was exhaust systems, and then the other was wheels, rims, hubs, and bearings. Another transport topics, avoiding or after treatment woes with preventive maintenance. The biggest problem we find with diesel particulate filters and that type of exhaust after treatment systems is that they're not as predictable as other things or other routine repairs and or preventive maintenance. We're going to talk about that, but basically some of the points that they put into reference to transport topics was that they suggest that you follow OEM specified preventive maintenance schedules. Cleaning of the DPF, usually depending on the manufacturer, 300,000 to 400,000 miles, depending on conditions. Regular inspections of the after treatment, making sure it's tight. Make sure that the unit is in operating condition. Paying attention to upstream failures, anything to do with fuel, oil, contaminants. You don't want to have your DPF having any other type of contaminants, besides your ash and your soot. Getting training for mechanics and or individuals to diagnose the root causes of the problem, so that you're not just changing out and or prematurely changing and cleaning DPF type systems. Also, treating tanks with additive, which actually can ensure injector cleanliness in reference to development of carbon deposits or internal injection deposits. And also ensuring diesel fuel meets OEM recommended specs. Fuel, diesel specifically, must meet ASTM D975 for ultra low sulfur fuel. The thing you have to remember is ASTM specs are minimum specs, so that once it's in your tank or subject to your technology, can drop well below minimum specs. So a normal, this is a caricature of a exhaust system. So important parts of this demonstration today, or this conversation today, are the actual combustion of the fuel and how it is actually reclaimed back into the exhaust is reclaimed back at the EGR valve. System works pretty well. So let's start at the beginning here. We combust the fuel. We bring fuel as well as air. It is compressed. The power stroke provides power to the engine, and the exhausted fuel heads upstream or up into the exhaust pipe. Depending on the ECU, or I refer to it as the ECM, the engine control module, depending on what workload that particular unit is under, a portion of the combusted exhaust gas is reclaimed at the EGR valve. So the EGR valve pulls already combusted fuel that contains soot, ash, the byproducts of combustion, heat. It continues down into the EGR cooler. The EGR cooler lowers that exhaust gas temperature, and then this is reinduced into the combustion air again in order for it to be put under pressure again and combusted. Ultimately, the diesel oxidizing catalyst prepares the exhaust for the DPF, the diesel particulate filter. This takes the ash as well as the soot out of the exhaust fumes, and then sends it on down via the SCR system. The SCR system takes the actual NOx, the greenhouse gases out of the equation, and then ultimately provides a inert, non-toxic type of emission up into the environment. And this is required by the EPA. As temperatures are higher for exhaust temperature, it's actually better for the DPF, for burning off soot. With the EGR valve cooling that exhaust gas temperature, this lowers that temperature of air coming in, and then ultimately the DPF may have to work a little bit harder. The reverse is that when temperatures are high, NOx actually is higher, meaning it has to work harder you get more NOx. Whereas with the lower temperatures, NOx is not as much, but it's harder on soot. These are all important parts of this system here, because what happens is that when the system is working properly and your truck is driving down the road at, let's say, 50, 60 miles an hour, maintaining a good exhaust gas temperature of somewhere in the vicinity of 900, 1,000, 1,100 degrees, the DPF works very well. When the delta P sensor notes that there's back pressure, what happens is that a passive regen happens. So we're going to talk about passive regen now, the different types of regens. Passive regens happen automatically. Your engine control module and your sensors set it up so that the soot that is being trapped at the point of the DPF actually is just burned off. And again, it does take a certain amount of exhaust gas temperature in order for that to be done. Where problems come in is that when you don't have enough exhaust gas temperature, and or you have a lot of stop and go type traffic, PTO use, and or high idle type of situations, you may come into what they call a manual regen. This is normally initiated by your operator. Actually, a lot of times he has to either hit a button and or initiate the actual manual regen. This is where a fifth injector, if there's 4 cylinders and 4 injectors, or what we call a doser valve, provides additional diesel into the exhaust pipe, which is then ignited to raise the exhaust gas temperature. If the regen is stopped or does not complete its normal process to burn off that soot, and it happens more than once, you are then a lot of times required to do what they call a parked manual regen. This is where you actually have to shut the unit down, or actually, I'm sorry, you have to park the unit and then actually press that button, and then it has to go through its regen. Can't move that or shut off the engine until the actual regen is complete and that soot is completely burned off. Manual regens require additional diesel fuel that's not being used for generation of moving the vehicle down the road. It also is in a situation where the driver is parked. He's not making deliveries to customers. So this is a typical DPF of how it's working here. We know that both ash and soot are part of the combustion process. Soot, again, can be, with the right exhaust gas temperatures, burned out of the diesel particulate filter. Ash is non-combustible. Ash is the portion that you normally would clean the DPF on a a scheduled basis. But what happens when you have circumstances or conditions that the DPF and in this case EGR would be overwhelmed by additional soot that the unit is being that is not used to. Again, these systems work pretty well in reference to burning off soot, and again ash builds up over time, but they were designed to to last a long time. But when soot starts being developed via a injector that is partially blocked, a rich fuel economy, that the injector is producing soot from a sooty burn. This is what overwhelms those types of systems. I happen to be on that National Bio Board, and as part of one of their seminars on fuel quality and technology that was coming our way. This was an example of a next gen diesel particulate after treatment type of system with multiple SCR and multiple DEF dosing sites. Low load or light load operations, or when you're first starting up, the EPA is concerned with greenhouse gases and specifically NOx being getting into the environment. So you're going to have multiple dosing sites for DEF, as well as multiple SCR type of systems that some of them will be heated, as well as you're going to have a normal diesel particulate filter also to do this. So it's not going to get easier, it's going to get more complex, but the systems will work with good fuel quality. So what's happened with our fuel and with EPA restrictions in reference to mileage, as well as particulate and greenhouse gases, OEMs have developed what they call high pressure common rail injection systems. High pressure common rail, when placed against and run with ultra low sulfur fuels, put an additional amount of pressure, pounds per square inch, as well as temperature at the actual injector. Where we normally see carbon deposits in older technology and legacy technology was at the tip of the actual injector. We're now seeing them on the internal parts of the injection systems. When ultra low sulfur fuel is compressed and at higher temperatures, the fuel is no longer thermally stable and actually cokes up. This is where varnishes and gums are actually forming on the inside of injectors. Just to give you an idea, I was talking to a mechanic that said, if I were able to take out the pin inside the injector here, that visual, and actually put a marker line on it, from a Sharpie on that, and then put it back into place, the restriction of just a marker line would be enough for it to disrupt the tighter tolerances and cause drag on that internal injection system. So we know that fuel is not 100% burned. The fuel that is coming into the side of the injector cools the injector. Some of it is burned, and some of it actually returns to the saddle tank. Because the unadvised fuel, the generic fuel, the diesel fuel, is under pressure and under higher temperatures, the fuel going back actually can develop some particulate that comes out of suspension and actually makes it down to the saddle tank. In addition, your saddle tank fuel is actually heated, which causes a thermal reaction with fuel itself, causes aging specifically. So this is an example where ultra low sulfur fuel met some injectors. We see the coking of the actual injectors. This would cause spray pattern differences, and ultimately not enough fuel and or too much fuel can cause problems with performance, as well as fuel economy deficits. Another example of a coked up injector, as well as the injector cup. Obviously, this would have had to been replaced. EGR valves also subject to high soot and high contamination. DPF plugging is also associated with this, but as we see by the example here, as sooty burned fuel or fuel that is laden with soot is reclaimed into the actual EGR valve, we see problems with DPF plugging, as well as EGR repairs and or performance issues. These are obviously going to come into play in reference to your bottom line, and it also causes downtime. Nobody likes to see a $10,000 bill. This was an unplanned or unscheduled repair cost, just as Transport Topics said that they're going to cost you quite a bit more. This happened to be a shop repair, but was unplanned. This happened to do with a EGR valve that had a 1/4 inch thick layer of soot. But ultimately, if you were to look at all of the sheets of this particular repair, you would have seen that there were bad injectors that had to be replaced. Typical injectors will run you, $6,000 in reference to the repair of that. But besides the actual inconvenience and hit on your wallet of this particular repair, what else does it hit? Well, it's going to hit your downtime. It's going to hit downtime. Your driver is either waiting for the truck and or has to jump into a additional truck, a loaner truck. It also hurts your brand because you're not providing, on-time deliveries to your customers. Hurts your customers because they're not able to provide their product. So ultimately, the costs that involved with this don't start at just the shop. If you can prevent unscheduled types of repairs like this, it's going to help you, your customer, and keep your brand strong. So temperatures we talked about, as temperatures go up on operating, it actually affects the fuel. You can see the combination of the fuel gets darker and darker and darker. This is what temperature does to fuel. Also, temperature has a tendency to provide internal as well as external fuel injector deposits. You can see the spray patterns. The first one, of course, in the center is just basically a stream. Doesn't give the power and or atomization required in order to provide good combustion. The one all the way to the right, of course, is good atomized fuel. Is going to give you the best performance. So these problems will downstream will cause filter blocking, as you see to the right, fuel economy deficits, increased fuel cost, obviously, shortened PMIs on fuel filters, as much as even half the time of a normal OEM, filter change, power loss we discussed, and then performance reduction or problems. You've probably seen these types of filters. They can be sporadic, but these are traditional thermal stability. This is fuel that is returned from the injector through the return fuel line down to the saddle tank and hits the first and secondary filtration. Filters have gotten smaller and smaller in reference to for microns. What we used to see as a 10 micron or even 15 at the saddle tank, and maybe 10 at the just after the fuel pump and injectors was down now to anywhere from 2 to 5 microns at the secondary, and then usually about a 10 at the actual saddle tank. When these, what we call carbonaceous deposits, we call them also asphaltenes, develop, it is due to the stress that the high pressure common rail injectors and then the temperatures put on unatomized fuel, unatomized diesel. These small, and of course this is electron microscope, this is what's showing what they look like. The fuel becomes darker. The filters are doing their jobs, but what we find is that many trucking companies or operators, even with older technology, a lot of older cat engines with a little bit higher temperatures are finding these in their fuel tank. And ultimately what happens is that these gang up on the filter, cause fuel starvation or cause a vacuum, and your engine and or your gauge tells you have to change this out. Otherwise, what's going to happen is you're going to be changing it on the side of the road. There are remediations, there are fixes for this. Specifically, by atomizing your fuel, you can actually prevent and eliminate carbon deposits and or varnishing, especially in high pressure common rail, high pressure fuel injection systems. The chart down to the bottom was a unit run with a additive, the specific additive, and provided a optimal range in reference to sticking injectors. The additive was taken away, as you can see. It was run for a period of time, and you saw a deficit in reference to sticking injectors. It was returned, and then ultimately was able to return those injectors from sticking. In the middle there is the filter blocking. We see what we refer to as coffee grinds, that real tarry residues that cause shortened preventive maintenance. Filters are not real expensive, depending on if you're buying OEM or aftermarket. But with a filter change can run you anywhere from $120 to $250, depending on what you're buying. So ultimately, if I'm able to bring you from a halfway to the goal of a OEM filter change, let's say at 20,000 miles, and also do an oil change at the same time, we're finding a lot of fleets and manufacturers that are having to replace filters at 10,000 miles or 15,000 miles and are not making it to a normal wet PM. Also maintaining and providing fuel economy. So this product will also provide stability to fuels, both biodiesel as well as petroleum diesel fuels for storage, and also provides that thermal stability so that you don't get the coking effect of that fuel. Available in a couple of different versions, winter cetane boost, as well as a winter product with cetane boost. This particular was an example. This was done by Dr. Ian McMillan back in 2008. So this was a unit. This was the internal of an injector. It was run for 166 hours with no fuel treatment. They are different cylinders, but different different injectors. However, when added with an antifoulant type of detergent, they were fine for 48 hours. The actual detergent and dispersants were able to provide a cleanup effect. With an additional 48 hours of antifoulant detergent and dispersant, we're able to provide a nice clean and maintained injector internal. Obviously, this would cause a situation where you wouldn't have the sticking or varnishing. In a case study done with an excavation company, this is one of my clients. They had a Cat D6T dozer. They were having all types of problems with it. They took the fuel tank out of it. They treated it for microbial. Nothing was working, basically. They changed the injectors. They were changing injectors on average every 158 run hours. Some of them were a lot less than that, like 60 run hours, 100 run hours. The goal was, of course, 250 run hours. These were the actual filters that were coming out of this particular unit for their unit number. I think it was 376. With a successful treatment of the fuel on a consistent basis, they were actually able to provide and increase the filter changes up to 257 hours between filter changes. Now, the goal again here was 250 hours, but this was a proactive change. Gary Shepard of this particular company, he's the fleet manager. He could have actually taken them out to probably 500 hours like he did his dump truck fleet. But he proactively changed these out at 250 because he had other maintenance concerns on certain wear points, on the hydraulics and on the boom, for the actual tractor itself. So he's happy at 250 hours. Wasn't happy at the lower filter changes. With that, I'm not sure what our time is here, but actually it's pretty good timing, 45 minutes. Happy to take questions. I do thank you for your time today. Always available. Here's my contact information, always available for, no obligation consultations. We help a lot of different customers all the way from, again, the terminal all the way down, single users. A lot of people with glider kits are using our product that have been experiencing, that have increased their horsepower by, turning up their injectors, finding some of these problems.
Thank you, Mark. If anyone has any questions, you can type those into the Q&A box at the bottom of your screen. It should pop up down there. We'll take a few moments to allow you the opportunity to ask Mark any questions. Like you said, there's his contact information, or there it was. It just went away.
Oh, hold on. Let me try that again.
All right. There we go. Yeah, Mark at yourfuelsolution.com is his email address. Look out for an email this afternoon with a video of today's webinar. And for those of you that joined late, we'll be able to make sure you get that so that you can see all of the information that Mark had for us. And for those of you that are watching later, I suppose you may have missed this the first time around. We're happy to provide that video. It will also be available on our website under our webinar catalog. I'm not seeing any questions pop in here, Mark, but I do want to take just a quick second to let everybody know that there's another free webinar coming up on February 11th. We'll have a pre-employment screening program webinar. PSP is a program that's endorsed by the Federal Motor Carrier Safety Administration, and that is free to attend as well. So be sure to take a look at our website, get signed up for that, and stay on top of all the news and events that we've got coming up. And if there are no questions, Mark, we'll let you go. But thank you so much for your time this morning.
All right. Thank you, Brandon.
Thank you.
Thank you all for attending.
Have a great day.
All right. Bye-bye now.